Trigonometric functions of angles is a third section of triangle, right triangle in a coordinate plane. So you place it so that an acute angle is at the origin. Then a side, one of the sides is also on the x-axis, as well as a right angle. In this position, we have a side x. We can call it x because it's on the x-axis, and that gives us actually the length of x, and that length of x here, we can mark it, and then the length y would be over here. This is our y. Hence, we have this point P, x, y coordinates. Now, looking at that angle theta, we can define the sine, cosine, and tangent for it. Sine would be opposite over hypotenuse, so y over r is our sine of angle theta. Cosine of angle theta would be x over r, since it's adjacent over hypotenuse. And tangent is opposite over adjacent. So if we look a little bit lower, you can write all these ratios just by looking at the triangle over here. And cosine of theta is x over r, and tangent of theta is y over x. Now, also, since it's a right triangle, you can find any of the sides if two of them are given to you, and you use Pythagorean theorem. If you recall, a square plus b square equals c square. Just in this case, we have sides x, y, and r is our hypotenuse across the right angle. To find r, you would take a square root of x squared plus y squared to find it. Now, why do we call it r? It stands for radius because it actually shows it is a radius, and if we drew a circle around, use this point and just drew a circle, it's a radius of that circle, and we would call it actually unit circle, which we will discuss later on. So we have more trigonometric ratios, as you know, it's sine, cosine, tangent, cosecant, secant, and cotangent. Now, what we can do, we can actually have this triangle in any quadrant, but you always place the acute angle at the origin and your right angle on the x-axis. So you can see it just in the negative x-axis. Now, what do we have here? If you look at this triangle, now this is still x-axis, so this is still x length. However, it's on the negative side, so that will be a negative. Here we have y, which is y is positive because it is on the positive side. It's at the top. So why is it this triangle on this side, right? So for example, if you were given a larger angle, let's say 135-degree angle, to find ratios of sine, cosine, and so on, you would actually look for a angle that is associated with that 135 degrees. And how would you do that? You would draw that angle, but then you would be looking for an angle between 0 and 90 degrees that can be associated with it, and that would be an angle that completes it to 180 degrees. So it would be this angle over here. And your theta that you would be looking at here would be this one over here. That would be the theta angle. There we go. Theta. Okay, there we go. So over here, we're going to fill in all the ratios that we have based on this angle. Now we will ignore for now the negative right now. I'm going to discuss it here below, how that works. Now, what we have, again, as before, this is your x length. Let's say it's x length. This is your y length. So, and the last one here is the r. The hypotenuse is r. So we can easily figure out what all these ratios are. So why don't you take your time for a moment and just figure it out, right? So just maybe let me do first one with you. So your sine would be just, again, opposite over hypotenuse. So it will be y over r, right? And so on. So pause it now and just figure out all these ratios for this triangle and this angle theta. Hopefully you have the same ratios. You got the same ones over here. If you look Here you have y cannot be 0 because again we cannot be dividing by 0, as well as over here x cannot be 0, x cannot be 0, and y cannot be 0 because these two sides can never be 0, and those two sides, of course, you'll find are based on those two sides. Now, when are the ratios positive or when are they negative? Depends which quadrant they are in. So if you recall positive function in quadrant 1, if you have your triangle over here, so let me draw quickly maybe with another color like this over here, and you have your x length and your y length, and this is your angle. Then we can see that x and y are both positive. Then you have r. Sine y over x, positive. Cosine x over r, positive. Tangent y over x, positive. And then, the other three are just the inverses of these three, and they also are positive. So you should understand that in the first quadrant, all of them are positive, okay? Now, negatives, we don't have any negatives ratios in first quadrant. Now, what about second quadrant? So this is this one, right? Now we can see here, let me switch again to black marker. If we have sine is y over r. It's positive. This is positive y, right? This is positive. It's the hypotenuse. So it's positive. So sine will be positive. Now cosine we have now x over r because it's adjacent over hypotenuse. This x is negative, so it will actually be a negative ratio. And since cosine and secant are inverses, secant will be negative as well. Now, sine and cosecant are inverses, so sine and cosecant will be positive ones in this quadrant. All the rest will be negative because, again, tangent it would be y over x, and x is negative, so it would be in negative. It has negative ratio. What about third quadrant? So again, if our reference angle is in the third quadrant, we would draw, let's say that's the angle. We would draw again a right triangle so that the right angle is on the x-axis. We will have this point over here, so this would be the y length, and we can see it's on the negative side, so it will be negative y, right? Negative y length. Here, this is negative x length. And this would be our angle theta at the origin. Now, how do those ratios look here? So sine is opposite over our r over hypotenuse. So it will be negative y over r. So it's negative. So sine would be negative. And again, sine and cosecant are inverses. So both of them are negative. Then we have cosine. Let's look at the cosine. So it is adjacent over hypotenuse. Again, negative value over here over the positive. So again, cosine is negative. So cosine and secant are inverses. So both of them are also negative. And then we have tangent. Tangent is opposite over adjacent. So you can see that we have negative value over negative value. So negatives are reducing or changing to positive. So tangent and its inverse cotangent are positive ratios in third quadrant. What about our last quadrant, the fourth quadrant? Again, if your reference angle is in the fourth quadrant, then again we draw, not very straight, I apologize for that, but just side toward the x-axis, or the right angle should be on x-axis again. This is our angle theta. If we look at that again, we have this length, it's associated with y, and it's negative, right? This is y, negative y, whatever values that would be. So this is negative y. And then we have here positive x, because it's on positive side of x. Okay, so now let's look which ratios are positive and which ones are negative in this quadrant. If we look at sine, so sine opposite over our r over here, so it's negative over positive. So it's negative ratio, it will be negative side. Then again, cosecant is inverse, so it's also negative. Both of them are negative. Now cosine, if we look, it's x, positive x, over r, so it's positive actually. So cosine in fourth quadrant is positive, and the inverse secant as well, because it's just the reversed. And tangent would be negative y over x. So again, one of the values is negative, the other one is positive, so it makes it negative, and its inverse cotangent would also be in the negative. So these are all trigonometric functions in all of the quadrants, something we gonna have to remember and practice a lot in order to remember. There's also mnemonic device here that can help you remember which the trigonometric ratios are positive and which ones are negative in which quadrant. So let me just show that to you over here. All sine is only positive in the second quadrant. Tangent is positive, only positive in the third quadrant, and its inverse, I should say, too. And the fourth quadrant is cosine and its inverse. So you can remember this as all students take cosine.